Guys, to your first official Algebra 1 flipped classroom lesson. So what I want you to know today is that throughout your career in algebra, you're going to learn that it uses lots of symbols and expressions that stand for numbers. So first thing I want you to do is write down the word symbols. And know that symbols simply stand for numbers. And those symbols we like to call variables. Now, variables comes from the word vary. These variables change. Okay, so a variable might look like V, might look like X or M. Variables are simply letters. So in algebra you will see lots of letters and they vary, and these letters stand for different numbers. Now we use these variables to write what's called algebraic expressions. Alright, algebraic expressions, they have at least at least one variable. Okay, so they have at least one letter in them, an algebraic expression. So let's just do this. For example, now, sorry about that. My pen just messed up on me, and as I'm learning this, we're just going to have to deal with that. Let me fix this. Sometimes when I change colors, I hit the wrong button, so that's my fault. Sorry about that. So, whenever I do an example, I'm going to just simply write EX for you. Okay, so you'll just do that too. So for example, if I just said n minus 7, this is an algebraic expression, and I ask you to evaluate, not just simply means figure it out, evaluate n minus 7 for n equaling 15. That means you're simply going to say, okay, n equals 15 here, so I'm just going to substitute that in. So instead of writing n minus 7 now, I'm going to say 15 minus 7, and I know that 15 minus 7 equals 8. Another example, I could put it over here. I might ask you to evaluate again y plus 8 for, let's say, y equals 9. Alright? So, you just simply substitute 9 plus 8, and now we know 9 plus 8 equals 17. So very simple. Variables just change according to what we ask you to use for them. So what if now we talk, that was with adding as a, oh my stars, I apologize again. I've got to grab my pen without holding the mouse on my pen. One day, I promise, I will get that straight. Alright, I'm just going to draw a line here. What if we talk about multiplication? Alright, so let's do this. I will use my real mouse here when I change colors. That way I don't use that pen mouse. What about look at that. I am so sorry, and I just pray that you bear with me as I try to keep that from happening. So sorry about that. Alright, let's try that again. And I'm still fighting with it. I don't understand why it's doing that to me. I profusely apologize about this. If you could see my face right now, it's not very happy. Alright, we'll try again. Alright, an algebraic. Oh my goodness. I am just being quiet right now, so I make sure I say nice things about this pen. Alright, we'll try one more time here. An algebraic expression using multiplication. Spelled that wrong. M-U-L. Alright, I'm going to show you what this might look like in algebra. There's several ways that this will look in algebra. You might see it actually written out 3 times a. See that variable right there? That makes it algebra. And you might just see 3 times a. Another way you might see it is 3 times a. Okay, so that symbol is what we're used to seeing for times. Sometimes you may see 3 with a dot and an A, and that dot simply means multiply. You may see 3 parentheses A. That means 3 times whatever is in this parentheses. Or you may simply see it written just as 3A. And all of those mean multiplication. Okay? Now, division, I'll draw a little line here so I don't have to make my page go up. Let's talk about what division might look like when you write division expressions. Algebraic expressions using division. Division might look like this. It may simply say m, there's your variable, m divided by 4. Or it may look like m with what you're used to seeing, this division sign, divided by 4. Or it may be m over 4 written as a fraction. Now I want to tell you this right here. All fractions are division problems. Division problems. And that's easy to think about if you think about if you divide a candy bar in half, 1 divided by 2 people, right, into 2 parts. 1 whole candy bar divided into 2 parts and wholes. That's why fractions are division problems. Just think of candy bars when you split them up with someone. Alright, so now that we've seen that, let's look at a couple of examples. Okay, scroll this up, and I'll do a couple of examples for you. Every now and then I like to change colors just so you can see the difference here in what I'm doing. Alright, so let's do an example. And if you see it say evaluate 5y for y equals 6. So that means you're going to, instead of putting 5y, it is equal to 5 times 6. And 5 times 6 equals 30. Another example you might see, let's do another one right here. What if it was x divided by 12 and I asked you to evaluate this for x equaling 36. So you would simply substitute 36 in for your x. So now it's 36 divided by 12. And you know 36 divided by 12 equals 3. Alright, another example, I'm going to have to move down here for this one, could be x divided by y. Now I will have to tell you that what these variables equal. For x equals 10 and y equals 5. So now you're going to substitute that in. Since x is 10, you'll put x divided by y equals 5. So 10 divided by 5, and we know 10 divided by 5 is 2. Alright, another example, we'll put it right here since we have some room. I'm just going to write mn. And up here, we know that if we see something like that, that it means we're going to multiply it. So, mn for, let's say, for m equals 2 and n equals 6. Alright, so that would be 2 times n is 6, and we know 2 times 6 equals 12. Alright, so that's what some algebraic expressions will look like in algebra. Let me talk to you now about what types of numbers we're going to be dealing with. I'm going to draw a line here to separate this. What types of numbers we'll be using in algebra. So I'm going to change colors for you and try not to change my brush size at the same time. So if you would draw me a big circle here, okay? And I'm just going to use this circle to put our numbers in. The numbers we're going to be using in algebra are rational numbers. Now, all of the rational numbers we're going to discuss later, okay, not today. But I need to show you those to show you that within rational numbers you have another group of numbers called whole numbers. And within that group of numbers, you have another group called natural numbers. Now, I probably should have used different colors here, but I didn't. So I'll change a little bit now here. Natural numbers are simply numbers that you naturally use when you count. Alright, and they come natural to you. So when we count, we say 1, 2, 3, 4, etc. That's the best way to think about it. There's only one difference between natural and whole numbers. Whole numbers simply include 0. And then they just move on. 1, 2, 3, 4, and so forth. Okay, so in algebra, we'll be dealing with all of these types of numbers. We'll get to rational numbers later, so you don't have to worry about those now, but I did want to show you how they connect. Now, one of the last things I want to talk to you about today is what's called the order of operations. You've probably heard this before. And order of operations, you want to look at grouping symbols. It simply helps you know, well, what am I supposed to do first when I try to solve this problem? What do I do next? So when you look at the grouping symbols, we're going to think about parentheses. Okay? You want to do those first. Anything that's grouped together in the parentheses you want to do first. And also we can consider a fraction bar a grouping symbol as well. So you may have something that's above the bar. Maybe you have like an addition problem or something up there, and then you have something below the bar. You're going to want to do that before you do any dividing. Okay, do this before dividing. Alright, so if we think about that, I've got a couple of examples to show you. Alright, change my color again so you can see these examples. What if I might ask you, or you might be asked, here's your example, to evaluate A times 3 plus B, and I will tell you that A equals 5 and B equals 2. So if A is 5, I'll put a 5 here. Okay, this is equal to 5 times 3 plus 2. I want to do what's in the parentheses first. So that's going to equal 5 times 3 plus 2 is 5. And now I can multiply and say that that equals 25. Alright, here is another example. I'll put it over here. X plus 5 divided by 2 times 3. And I'm going to tell you for X equals 7. So all I have to do is substitute that in. So this is going to equal 7 plus 5 divided by 2 times 3. I want to do what's in the above the fraction bar and below the fraction bar first. So 7 plus 5 is 12, and 2 times 3 is 6. So now I can divide. 12 divided by 6 equals 2. Alright, we'll do a couple more examples and we'll be done. I'll just keep that same color. Show you here is another example. I'm just going to do that. Alright, what if we have s, this variable s, times t minus 4? And I'm going to show you that s equals 4 and t equals 8. Alright, so that means 4 times, if t is 8, that would be 8 minus 4. I want to do what's in the parentheses first. 4 times 8 minus 4 is 4. And we see that that equals 16. Alright, so parentheses first, what's above and below the fraction bars, and then we can do the rest. So the order of operations, let's take a look at that one more time just to stress it. Well, I'm sorry about that. I went so long and didn't have that mess me up. For some reason this time it did. Alright, we'll try that again. All I wanted to do is draw me a line right here. Alright, so sorry, I'm having trouble with my pen again over here. I don't know why it's wanting to do that. Alright, what we want to do first is what's in the grouping symbols. Second, we can then multiply and divide from left to right, just like you would when you read. Lastly, one of the very first things you learned when you were younger, you're going to add and subtract. Also from left to right. And if you follow these rules, you should have a good time getting started in Algebra 1. Thank you very much, guys.